All right, hello everybody, this is Miss Piekarski. This is the last of the new material I'm going to show you, and most of you have seen compasses before, you've used them before. What we're going to do is we're going to compare our unit circle on the left with a compass on the right, and you'll notice that both of these have the letters A, B, where's C, C, A, that's a B, and C. So these letters correspond to the values. Let's see, let me change pages. These values here, your A, B, C, D, E, F, G, all the way down to L. Okay, so they're on the unit circle and on the compass. That's what those letters are showing you, is where those directions are. All right, so let's talk about the unit circle and the compass. They're both very similar to each other. Main differences are with the unit circle, you start at your positive x-axis over here, and you're going counterclockwise. So right here we're at 0 degrees, we're at 90 degrees up here, 180 degrees here, 270, and then back to 360. Okay, that's with the unit circle. We've seen it before. We've done lots of things with it. We're very familiar with this. Okay, now with the compass, most of you know that with the compass you have north here, south here. I know it's a little bit hard to see. Let me rewrite that S. Okay, so this direction is south. And then you have east here and west here. Okay, so on the compass, those are north, south, east, west. We all know those directions. Okay, those of you that are in like JROTC, you probably did a compass orienteering class. Any of you thinking about joining the military, you will become very familiar with compasses, and you'll learn how to navigate with them. All right, so the whole purpose of a compass is navigational. Okay. Lots of sailors use compasses, ship's captains, airline pilots, they all use compasses for navigational bearings. And so when you're using vectors and you're navigating different locations, a lot of times you'll be given your navigational bearings, and before you can use the vector formulas, you have to change the navigational bearings into rotation angles here. Okay, so basically what happens is a lot of times ship's captains use the navigational bearings, and they are used to either converting it, or sometimes they might have something that, like a computer, that might change or convert it for them. But a lot of times they have to do it on their own. All right, so let's go ahead and get started. So in your notes, you have these symbol, or this unit circle and the compass. You also have a list, and it tells you to label each angle or direction on the diagram above, then tell the degree measure that would be used in each of the different systems. So notice that both the rotation angle on the unit circle uses the little degree symbol here, and the navigational bearings also uses the degree symbol. Okay, so you really can't tell if you're just looking at the angle, you really can't tell unless you see this little bearing symbol or the theta. Okay, that tells you whether you have a rotation angle here or a bearings here. All right, let me see. Okay, so let's go ahead. At north, on the compass, you're at 0 degrees. Did I say that already? That the compass, you start at north and you go you go clockwise. So north is 0 degrees, east is 90, south is 180, and west is 270. So it's a little bit different. All right, let's look at this. So again, we said on our bearings, we said that south was 180. But on the unit circle, it's negative 90 degrees or 270 degrees. East is 90 degrees for the bearings, west is 270. And then we know that on the unit circle, 0 degrees is east and 180 is west. Okay, so northwest, that's a location we've already seen before in one of our problems. Northwest is essentially is halfway between north and west. Okay, so notice on both of them, that's our E. Well, we know from our problems earlier in this unit that northwest is 135 degrees, but that's on the unit circle. On the compass, you're going all the way around. Whoops, it's not a very good circle, is it? On the compass, you're going all the way around this way, and so it's going to end up being, we know this is 45, so 360 minus 45 will tell us how many, or the angle on our bearing, and it ends up being 315 degrees on the bearings. Okay, and so same kind of thing with southwest. Hold on, there we go. With southwest, you're going halfway between the two on both of them. And here you find it's, let's see, 180 plus 45. Are we at 125? Okay. And then on the compass, or excuse me, 225. And then on the compass, amazingly enough, it's also going to be 225 degrees. Oops, I spilled the beans on the northeast. So let's look at the southwest and northeast on our compass. Okay. Yeah, so southwest, you start at north 180 degrees, another 45 degrees, you get to 25 degrees. And then northeast is here, and you start here, it's 45 degrees. Amazingly enough, on the trig table, it's also 45 degrees from here to here. Okay, not trig table, on the unit circle. Let me erase all this extra stuff so I can see better. All right, so both of those are going to be 45 degrees. And then east, southeast, it tells us on the compass bearings we're at 112.5 degrees east, southeast. So let's find on the unit, or on the compass, where east, southeast is. So if we're at southeast, we're here. So, and then halfway between southeast and east is going to be approximately right there where your H is. And half of 45 is what? 22.5. So you have a 90 plus 22.5 there, and you get 112.5 degrees. Well, on the unit circle, it's still the same location. Notice H is still in the same place. But instead of starting here, we're starting here. Now, we can either go around this way and have a positive angle, or we can go this way and have a negative angle. Either way works. Let's look and see on here which way they do it. They might do the negative angle, I don't know. Yep, they do negative 225, or 22.5. Okay, and then do the same process for the rest. I would like you to go through them. West, northwest, halfway between northwest and west, you get 157.5 degrees. Okay, and then these two, I want you to look at your unit circle and your compass. Find negative 75 degrees on your unit circle. Figure out what letter represents that. Go to your compass, find the same letter, and start at north and see how far it is. It should be 165 degrees. And then 240 bearings, look on your compass, find that, find the letter, go to your unit circle, find the same letter. It should be 210 degrees. And then on the unit circle, 105 degrees will be 345 bearings. Okay, so just with this table, you should have realized that, well, most of you probably didn't notice it, but it's a lot of work going back and forth, back and forth, back and forth between the unit circle and the compass. It takes a lot of time. There is a simple formula you can use every single time. So if you have your rotation angle, let's say we know what the rotation angle is and we want to convert it to bearings, all you have to do is you take 90 degrees and subtract that rotation angle that you have. That will tell you what your bearings are. If you have your if you have your bearings and you want to know the rotation angle on the unit circle, you would do the same thing. 90 degrees minus your bearings will give you your rotation angle. 90 degrees minus the rotation angle gives you your bearings. Okay? Very similar. It doesn't matter whether you have your rotation angle or your bearings. You can get the other one by subtracting what you have from 90 degrees. All right, so let's check it out and see if it works. Let's pick one of the ones that are kind of ordinary. I'm going to change my color. Let's do blue. All right, so let's see one of the ones that we have. Here we go. 90, we have the bearing, so 90 degrees minus 112.5. Okay, if you put that in the calculator, you will get negative 22.5. Okay, I'll let you put it in the calculator on your own if you want. Let's look at another one. Let's see. Trying to find one. Here we go. Let's say we know the bearings are 315 degrees. How did we get 135 degrees? Because if you do, let me do it this way. If you do 90 minus 315, okay, you don't get 135 degrees. 90 minus 315 degrees gives us a negative 225, but how did we get the 135? If you take 360 degrees and subtract or add our negative 225, but since it's negative, we could just subtract 225. What do you get? Let me change the shape of my box so it all lines up. There you go. You will end up getting 135 degrees, okay? So I know the formula looks crazy, okay? Because if you do negative 90 degrees minus 315, it doesn't look like you would get 135 degrees, but you have to then change your negative angle into a positive angle and you get 135 degrees. All right, so one other thing I want to point out, notice that your domain for your bearings, your angle has to be between 0 and 360 degrees. So we never have a negative bearing. Okay, you can have a negative, we can have a negative rotation angle. In fact, we have a negative one there, negative one there, negative one there. We're comfortable with negative rotation angles. It's okay to have negative rotation angles, but you will never, ever, ever have a negative bearing. So that's one thing that is different between degrees and, rotation angle and bearings. All right, so that leads us to this. Even though rotation angles can take on any value, positive or negative, navigational bearings are limited to 0 or to 360 degrees, so they can never be negative.